Hello, everyone. My name is Alex,
And I'm Sophie.
and we
We
are
are
the
the
Science
Science
Kids.
Kids.
So today we have a guest for our very first Science Kids interview, and we are more than excited. Like I cannot explain to you how excited I am.
Yes.
So, Sophie, you want to introduce our guest?
Yes. Our guest today is Jim Montgomery. So, Jim Montgomery is a systems engineer and you've worked for JPL for over 20 years. He's helped develop and test technology for ground and aerial robots, as well as create planetary landing systems, which is
Yeah,
incredible.
I like to describe it like this. If aeronautical engineering was an Olympic sport, he would be a two times gold medalist for each of the Mars rover missions he worked on.
Yes.
You're making me blush.
All right, so let's get right into it, shall we?
All right.
Okay,
Let's go.
so let's just begin, from the very basics. What got you interested in science in general, and then what got you interested in space and space travel?
Those are great questions. And I think so. As a kid, I grew up in southwestern Michigan, out in the country, and so the night sky was incredible. And so I'd look up at night, and you just see all the stars. You'd see the Milky Way galaxy. And it was just incredible. And then also it's immersed in nature, the natural world. Deer and turkeys and things like that just come through the backyard. And so just always made me question and wonder about things. And then fast forward to age 5, that was 1969. That's when Neil Armstrong and Buzz Aldrin stepped foot on the moon. And my parents told me I drew a picture of a rocket ship, put it on my bedroom wall, and said I was going to be an astronaut when I grew up. And so, right, so you just start checking the boxes off. What do I need to do to be an astronaut? Oh, math, science, engineering. And it just kind of went from there.
That's
Yeah.
awesome.
That
All
thing
right.
that sparked your curiosity. It's amazing. Yeah.
Mhm.
All right, so okay, let's ask this. So when you were younger, did you know that you wanted to work at NASA, or generally, did you know you wanted to uh, go into space exploration, space travel, and aeronautical engineering?
Definitely not aeronautical engineering because I didn't even know what that was. So it's, like anything, it's sort of a journey and you don't know what you don't know. But that's the beautiful thing about like science and exploration. We kind of build upon, the shoulders of others, and so basically, as I went to school, I became a voracious reader of science fiction like Jules Verne, and that, Isaac Asimov, and that just makes you just think and wonder. And then when I went to college, I was computer science was my background, and so from there I got a job out here in California, as a co-op, and from there I learned about electrical engineering and taking software and hardware together. And then when I was getting my PhD at USC, I came across a lab where they're like playing with flying robots. And I go, this is amazing. I can actually have a robot fly. And so we turned RC model helicopters into flying vehicles by putting computers and sensors on board and programming them. And then by doing that, and actually, I'll take one step back, right? So my goal was, I want to be an astronaut, want to be an astronaut, want to be an astronaut. I saw Carl Sagan talk on Cosmos, I was like, wow, to explore the universe, how amazing would that be, right? And so again, you check all the boxes. And so it's like, okay, well, I need to basically get my doctorate because I was not a military pilot. So it's either like, payload specialist or military pilot on the space shuttle. And so I took the first route, right? So I want to get my doctorate. That's like taking the Russian language in college because we were doing a lot with the Soviets back then. So ya gavru по-русски очень плохо. I also means I speak Russian very badly, which is true. And so
Wouldn't
I
tell.
guess,
I wouldn't be able to tell.
and so I did all these things to become an astronaut, right? And I applied 6 times. And I tell people this, one of the fundamental things I always tell people is follow your passion. I don't care what it is. It could be dancing, it could be cooking, it could be an auto mechanic, it could be sports, it could be an astronaut, right? And follow your passion and good things will happen. Because I followed my passion, I got all those things, I checked all the boxes or many of them, and I applied 6 times and I got turned down 6 times, to the astronaut program. But in getting my doctorate, it opened the door to a job at JPL. And so now I get to explore the universe with our robotic surrogates, right? So Curiosity and Perseverance. I've worked on both those missions, and so we get to see through the eyes of Curiosity and Perseverance, and now Ingenuity, flying on Mars. So it's an amazing journey, and I think as long as you're following your passion, good things are going to happen.
What was your path to working? To working for NASA, and when did you join?
Yeah, so that's a great question. I kind of alluded to that already, right? It's
Yeah.
like, so again, I got my high school degree in South Haven, Michigan, a small town in Michigan over here on the southwestern corner of Michigan. Then I made the big jump over to Ann Arbor, Michigan, where I got my bachelor's. And then I flew all the way out to California. I think it's the right direction. Yeah, out to California for my sophomore year in college for an internship program. And I always tell students, internships are a wonderful thing to do because you get to understand, what you like and don't like about a particular business. You become a known to those companies, and they very times they'll hire you. So when I look to hire somebody, and I don't do a lot of hiring anymore, but on person A versus person B, if they're all things being equal, one who's at an internship, I would go with them first because they've already got work experience. So I came to California. My first internship, I was a pure computer science. So it was like database, compilers, software engineering, that kind of stuff. But I discovered electrical engineering, and they had me working on this hardware system, what they call a real-time computer system, where your software would basically be running in these really tight loops with deadlines and things like that. I thought, well, this is really cool, software and hardware together. So I went back to Michigan. I started taking all these electrical engineering classes, so I could learn about combinational circuit design and things like that, digital logic. And that was, again, the merger of hardware and software together, but those were stationary systems. And so I worked at, so then I did internships 3 times. And then when I graduated, Hughes Aircraft Company, where I did the internships, hired me fresh out of college. Wow. So while a lot of my friends were stressing about, job interviews, I was like already kicking back and enjoying summer because I knew I had a job, when I graduated, which was nice. And then 4 years at Hughes, I decided I wanted to go back and get my master's. And when I went to, and I was very much interested, I started becoming interested in robotics. And so kind of a new field. And so that's what I was doing at USC. And then I went on and said, well, I'm making my doctorate now too, because again, I want to be an astronaut. Plus, I really like this stuff about autonomous robotics. So my thesis was in the area of getting RC model helicopters to fly autonomously. And so we got a contract from DARPA based upon we won a competition in Georgia back in 1994. When we got our helicopter got to fly autonomously for a whole 19 seconds. Wow. Which back then was revolutionary, but now you buy a drone and they fly out of the box and they do GPS waypoint following and blah, blah, blah. Back in the day that didn't exist. So we actually developed that technology. And so DARPA gave us a contract. We happened to be at a DARPA demo, and there were some JPL folks there with their little ground robot, and they saw our flying robot and they go, wow, we want that. And I said, well, you can have our flying robot, but you got to hire me too. So that's how I got my job at JPL. True story.
Wow.
And that was back in 2000. And then it's just been an evolution since then.
That's amazing. So you designed that and I'm assuming like back then the technology was very different. You didn't use GPS like most modern drones do, that use sensors or something to that effect?
That's exactly right. So there was no GPS. That's how old I am. So we, and there were no computers that you could buy, like Raspberry Pis, that stuff didn't exist. So we had to go out and buy like little chips, 68332 microcontrollers made by Motorola, and we had to wire wrap them ourselves, and there was no, we couldn't afford like a $60,000 inertial measurement unit. So we had to go ahead and make a poor person's attitude control system with little Polaroid ultrasonic transducers that could actually tell you from time of flight distance to ground. So we put 3 of those on our helicopter, 2 on a crossbar and 1 on the tail. And if all 3 were reading the same distance to the ground, and we assumed we're on level ground, we knew we had a 0 roll and a 0 pitch orientation. And that way we can maintain our flight. And so then if you want to go ahead and fly forward, you had to pitch down. So you would actually go ahead and you start to write these control algorithms that would take that sensor data, run through the algorithms, and then give control inputs or outputs to the servos to go ahead and get the helicopter to fly.
That is incredible.
Yeah, it was pretty cool.
That's some cool stuff. So
Definitely.
Wow, that's a really creative method too. So you have readings from 3 different regions, and if they're reading the same thing, then you can accordingly fly the helicopter.
That's right. But there's limitations, right? Because if you flew and you suddenly went over terrain, right, there's a rock in front of you, and if you came up, so the rock's here, the surface is there, and as you fly, right, you get here, and suddenly it's going to think, oh my goodness, I must have this horrible pitch down. So like it would do that, right? So you would actually you fly back away. So you couldn't, it was only good for level terrain.
Yeah, that makes sense.
Right.
Very, very interesting. Very interesting.
Definitely. Absolutely.
All right, so thank you for telling us how you got to that point. Let's start talking about what you're doing right now.
Yes. What is your current job? How would you describe your job?
Yeah, what do you do?
It's the most awesome job in the universe.
I would imagine.
Yeah.
Getting to explore the universe, right? So, broadly speaking, when we do these Mars rover missions, you have multiple phases. There's the whole, conceive, design, build, test, verify. That's that part of it, right? And then we get into what we call the operations phase. So it's basically assembly, test, launch operations, where we assemble the spacecraft, we test it at JPL, then we ship it down to the Cape, and they do integration with the rocket, and they do test down there and launch operations, then we launch. And then we have the phase, which is called CEDL. So cruise, and then entry, descent, and landing. So we launch, we cruise to Mars, and then we come into the atmosphere for the 7 minutes of terror, where we have to go from 12,000 miles an hour, at the top of the Russian atmosphere to landing safely, touching down, very gently in 7 minutes. And that's entry, descent, and landing. And then once you land safely, then you have surface operations. So I was part of the CEDL team, and we developed new technology called terrain relative navigation. And this is super exciting. I started working on this research back in 2004. So basically, 17 years ago. You have to be very patient in this job. And so what it was it gave the spacecraft the ability to land on Mars with its eyes open for the first time. Every time before that, if you remember the Pathfinder mission, the Mars exploration rover missions, they had these huge airbags, and they would just basically bounce up, they land on the surface, they bounce, and completely blind. And Curiosity was too large for the airbag thing, so we did the rocket powered jetpack, where we come in on a parachute, we slow down, and then the rockets fire, and we slow down, then we come and we do the little sky crane maneuver where we lower ourselves down like a spider on a web onto the surface, and they're ready to go. But even Curiosity still landed blindly. So we had to go to Gale Crater, which is kind of like, picture like, the Mojave Desert, or even better, a dry lake bed, right? Very flat, not a lot of hazards. And you just roll the dice, and you hope that, if there's 1% hazards, you got a 99% chance of not hitting a hazard. But the scientists, again, the one of the big goals is, right, answering that question: are we alone in the universe? Is this it? I tend to think not, but you got to prove it. So the prior Mars missions were, I'm going to test you guys. What are the 3 things that is required for life as we know it?
Well, okay. I'm assuming one of them is water.
Yep, liquid water. We depend upon water.
I've read some stuff about silicon-based life, but I'm assuming one of them is also carbon.
There you go. Organic life forms. Very good.
Okay. And the other one, I was gonna say oxygen, but I do remember a period of time when oxygen was toxic to like billions of years ago.
Right.
That's right. And there's anaerobic bacteria, right, that are quite fine without oxygen.
Yeah. So what would the third one be?
What do you do at least 3 times a day?
Food.
That's right. A source of energy. There you go. Yep. It's funny. You got the organics, which most people don't get. But yeah, that's it. Right. So we've had a multi-decade arc of looking for life elsewhere. So basically the first thing, water, Mars, right. There's no evidence of, at least there's no evidence of standing water. We know there's none, right? Because there's no atmosphere, and the pressures are such that would just basically boil away. So we had to prove, there's evidence of past water, because you can see like big, looks like, water filled. As a matter of fact, Jezero Crater is that very thing. It was a huge crater filled with water with basically a river flowing into it. And you can see like the river delta, right? So it's past evidence of flowing water from a river into a crater that was a huge lake. Wow. So we know that, I'm sorry?
So there's evidence of rivers on Mars.
Exactly. And we know for sure that, in the past, basically about 1 billion years ago, that there was still water. It was a wet, warm Mars. So check that box, right? There was water, but now is there water? So we landed the Phoenix lander at the south pole of Mars. I believe it was south or north, can't remember which. And it had an arm. It reached out and grabbed through the soil and came up. And basically there was ice, water ice. So check that box. There's actually still water on Mars. And then Curiosity, the Mars Science Laboratory, the next mission, basically it was able to prove with its onboard science payload that there are organics on Mars. So check that box. And there's already energy, right? So boom, boom, boom. We know a billion years ago, microbial life on your arm would have been quite happy on Mars. It had all the resources for life, right? So, but that doesn't answer the question, was there life or is there life, right? And so that's now the mission of Mars 2020 Perseverance rover. And it's got a variety of science payloads now that can look for the biosignatures of life, we call it. You know, like stromatolites in Australia, for example. If we could find a stromatolite bed in Jezero crater, that would just be smoking gun, boom, done. You know, drop the mic. There was once life on Mars. You know, we've proven that, right? And what a paradigm shift in the way humans think about themselves, right? Wow. It'd be kind of like that moment, you know, when Galileo and Copernicus said, humans, you ain't the center of the universe, right? You revolve around a bargain basement sun in a bargain basement galaxy. So get over yourselves.
Groundbreaking.
That would be groundbreaking. It would be truly incredible. And I don't want to go too far in time since you've kind of gone on for a while now, but I do have one question about this because if that were the case, that we were to discover proof of life on Mars, would that kind of change the way we think about evolution as well? Would there being a chance that life came from another planet and started evolving on Earth?
Yeah, that's a great question, right? The question becomes, and you're absolutely right, right? So even if we did find evidence of life on Mars, there's the whole, I think they call it panspermia, right? Where basically life seeded, you know, it came on Mars first, and then basically maybe it was transferred to Earth and basically evolved here, you know, separately, but it still is connected. So you still have to prove, right? Were they independent events or are they still a single event that spread?
That'll be very interesting. But yeah, it's incredible work, and please let us know if we find out anything.
Absolutely.
Well, actually, I'll tell you what, you can do your own, you can be a citizen scientist. We have a program at JPL. Just go to Mars 2020 Perseverance rover, and there's ways to participate. And you can look at the images. The raw images are coming down daily. We've got plenty of citizen scientists who are like building up, they're stitching together the images and making their own panoramas. They're doing 3D maps. They're looking for science already. So you guys could do that as well.
That's amazing stuff. That's amazing stuff.
Absolutely.
All right, so let's see. So let's ask another question about the work that you're doing right now. What's the biggest challenge that you faced? Not even during your career, just generally. What's the biggest challenge you faced, and how did you overcome it?
I would say probably one of the biggest ever was getting my doctorate, because you know, I was working at the time, and it was hard because I had already tasted the good life of working, you know, playing here in California, playing volleyball, hiking, backpacking, a lot of fun stuff. You know, then suddenly you're basically studying every day. Your friends are basically, hey, come out, let's do this. I say, I can't, I got to study, you know, and they stopped calling me. You know, and then also, you know, you become a poor starving student, you know, you don't have the income you used to have. So it was hard. And then also work was nuts, you know, it was just a lot of pressure. So you had the pressure of the doctorate, you had the pressure of work. And it took me 9 years to get my doctorate. And I actually almost quit. I tried to quit. I was going to get my professional engineer's degree because I just had it, you know. And my wife, well, my girlfriend at the time, asked me this question. She goes, have you tried your hardest? And I'm like, no, I haven't. I gotta keep going. So I have her to thank for my doctorate, actually, and actually my job at JPL. If she wouldn't have asked me that hard question, I would, who knows what would have happened? I might have quit.
That's an amazing story. So actually, we made a mistake. We should have introduced you as Dr. Jim Montgomery. So
that's okay. I'm Jim.
My apology. All right. So let's ask some more questions.
Yeah. Well, we know what personal struggle you've experienced in your career, but what's a kind of an extraordinary moment that you've experienced in your career?
That's super easy. Landing on Mars the first time.
Yeah. Okay.
Yeah. It was amazing, right? Because you worked so hard. You know, I started working on the Curiosity rover mission in 2006, and we landed in August of 2012.
Wow.
And that was 6 years of, you know, 6 and 7 days a week, 10, 12, 14, sometimes 22-hour work days, at the worst of it. And then there's this tremendous pressure, will we succeed or not? Or will we make a new crater on Mars? We actually I have a good friend, Miguel San Martin from Argentina, who's basically the father of the guidance navigation control system for Curiosity. And we had a gathering for the team a little bit before landing. We're barbecuing, having a good time. And Miguel just starts bawling, literally crying. I'm going, Miguel, what's up? He goes, I hope we do not disappoint.
Mm.
You just feel the pressure of, there's billions of people on the planet pulling for Curiosity and hoping that we don't, fail. And so the same thing. And so anyway, so when we landed, right, it's just like that tremendous pressure is gone. The elation of, wow, we've landed a robot on Mars. A large fraction of the world's watching, and it's an indescribable set of emotions that I wish everyone could experience at least once in their life, because it's overwhelming. It's in a good way.
That's incredible. And I would imagine that would be an incredible experience.
6 years of hard work nonstop, and it paid off. I feel like that's, just thinking about it, is just incredible.
Yeah. Well, and then the next mission, and I kind of alluded to this terrain relative navigation system I was talking about. Now we have a camera on board. As we land on Mars, we take images of the surface, and we have a map on board. And if you ever hiked before with a topographic map, you can look at the distance at like mountain peaks. Boom, 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 draw a line back, and where those lines intersect, that's where you're at. And so that's essentially what we do now with terrain relative navigation. And I started working on that system in 2004. And so we went to Jezero Crater, where you had like a 15% chance of death if you just landed blindly, like roll the dice I talked about. This time now you load the dice, because now you know where the safe places are at versus the hazardous, but you got to know where you're at first. So if our system would have failed, our lander vision system would have failed, where we're back to roll the dice, and it would have been a 15% chance of death, versus with our system, it's a 1% chance. So for me, I'd worked, 16, 17 years of my life on this system. And now I felt like, I hope I and my team do not disappoint, because if TRN fails, there's a high chance that we're going to just, perseverance will be nothing. And then ingenuity would not have happened. Right. And so anyway, and then so that was even more incredible, that experience. So yeah, I feel so blessed and lucky to have experienced 2 Mars landings. They're intense.
That's amazing. And when you were talking about the map, that kind of gives some perspective to me, because sometimes when I think and talk about Mars, I just think about it as like one blob of a planet, but I forget like there are different craters, different peaks, different locations on Mars.
Yeah, there's a whole, and that's a whole, this whole field of astrobiotics and astrogeologists. It was kind of neat when we settled on, this is all about science, right? So JPL and NASA said, we're going to Mars. Scientists, tell us where you want to go. And they had what they called the landing site workshops. And all across the world, groups would come and say, we should go to Jezero Crater. We should go to, Valles Marineris. We should go to this, we should go to that, right? And it was driven by the science. And all the groups would vote, and they would rank the different sites. And it came down to basically the scientists wanted to go to Jezero Crater. And so you're right. I mean, every different area is very different. If you only get to land once every 10 years, you want to do your best at finding a place where you can hopefully carry out the science that you hope to do.
That's awesome stuff. Yeah. That's awesome. All right. So I have an interesting question. This is something that I've been wondering for a long time, but I think it would be better if I got perspective from someone like you who's in that position. So when you're preparing to land a rover on Mars, I imagine there's so many different factors that go into it, like the different gravity of Mars, the atmosphere. What are some of the factors that go into it that people normally don't think about when thinking about space travel?
Another good question. Yeah, so we have this phrase at JPL, we call it test as you fly as you test. And so you basically want to test your systems like you're going to fly them at Mars. But there's differences, right? So for example, the gravity of Mars is 38% that of Earth. The atmosphere at Mars is a biggie, right? If you're at the surface of Mars, it would be like 1% that of Earth, so you're basically at hundreds of thousands of feet. I can't remember the exact number, but it's a very high altitude here on Earth to get the same type of pressure. So you can't actually test it exactly on Earth like you would at Mars. So you have to sort of take those things into account. And you do the best you can through simulation, modeling, analysis, a lot of math, a lot of physics. So it takes a broad diversity. And that's the cool thing about JPL. I mean, any kind of human being you can think of works at JPL, all across the world, right? With various different skill sets, and it takes all of us, and not just at JPL, but we have vendors, that we work with. That who built the parachute was this company, that's not JPL. We don't have that expertise. Or like very low temperature actuators. We don't build those at JPL. I had to find somebody else. All the science payloads. We went to Arizona State, to build, on and on and on. So long story short, it takes a village, as it were, a worldwide village to do these missions.
I would imagine so many different things that go into it. All right.
Okay. Well, considering what we've talked about recently, what we've talked about right now, what do you think is the future of space exploration? What do you think the future holds?
Well, I would first suggest reading the latest science fiction, because I think many, many times, right, just like Jules Verne, right, a lot of what he envisioned in his science fiction has come to pass. Isaac Asimov with his robotics, so science fiction, I think, is always a good place to start. The dreamers, and I think if a human being can conceive it, we can many times make it happen. And that's the beautiful thing about NASA and JPL. We have a 10, 20, 50, 100-year vision. This is no lie. We got people at JPL actually working on warp drive. So who knows? We might have warp drive someday. I don't know.
That's incredible.
if you ever figure that out, my mind will be beyond blown. That'll be incredible.
Yeah, people. I mean, it blows my mind. So we have these things called TRL levels, technology readiness levels, from level 1, which is warp drive, to level 9, which is we landed on Mars. So like TRN, we had started out at like level 1 concept, back in 2004, and we landed on Mars in 2009. But in between that, I'm sorry, at level 9. But in between that, there was a lot of steps, to mature the technology. So yeah, so I think again the sky's the limit. I do think that very soon we'll be able to have humans back on the moon. Mars is a lot tougher. I don't think people really realize we humans. That's why I'll put a plug in real quick. Actually, for JPL, we do a lot of Earth and climate science, and I'm very passionate about our pale blue dot and doing what I can to basically make sure that you all and everyone else has a livable planet that's full of biodiversity of life. And when you look at Mars, it makes you really realize just how precious and beautiful life is, and that diversity of life. And I mean, Mars was once warm and wet, and it might have had life, and now it's pretty dry and desiccated. And so I think I love that JPL and NASA has very strong Earth science and climate science programs. So actually, if you come to JPL, you might even find you might want to work on some of those. There's no shortage of cool things to work on and very meaningful things to work on, which I think at the end of the day, to have a life of purpose where you basically been able to do, make a positive difference somehow, whether it's increasing the knowledge of humankind or making for a much more beautiful, peaceful, biodiverse world. That Star Trek vision.
That's
you raise a great point, though, because when you think about like some of the harsh climates on other planets, and some other planets who like are complete gas, like Jupiter, it puts into perspective how amazing this planet is, and we're slowly destroying it, which is kind of sad to see. So
that's right. And I think, Carl Sagan, I spoke about him before, Cosmos back in the 70s, just really, it blew my mind and opened my mind. And he was talking about climate change back in the 70s, right? And they talked about comparative planetology, looking at Venus, right? Venus is greenhouse, the greenhouse effect gone awry, and that's a cautionary tale for us here on the planet, here on Earth. We don't want to have a greenhouse effect, positive feedback loops that basically get out of control. So we can use looking at other planets to inform, what could happen on Earth if we're not careful.
100%. All right, so I have a question. This is something that, well, this is our first interview, so we plan on asking this question to all of our future interviewers as well.
Okay.
So what is your favorite topic, formula, phenomenon, event, anything in science? You can take it.
Yeah.
Think about that for a minute. So what's my favorite event, phenomenon, or what?
Topic, formula, anything.
Yeah.
Just.
Oh my gosh, that's like choosing your favorite child. What are you talking about here? It's all awesome. I think I'm gonna cop out a little bit, just talk about the beauty of the scientific method. Basically it all kind of springs from there, and it allows we humans to basically hypothesize about things, observe the natural world, and either go ahead and corroborate our hypotheses or modify them. And it basically allows us to basically plan, think, and conceptualize and turn dreams into reality. So yes, I think the scientific method.
That's a
I'll go with
great
that.
answer. That's a great answer. And if there's no correct answer to that question,
Yeah.
but if there's anything that's closest to the correct answer, it's that, because everything stems from that, the scientific method. Yeah, I
Good.
love
I'm glad I set a high bar for your future interviewees.
Yeah.
Yes, they're gonna have to surpass that one. All right. So for a final question,
Yeah.
let's see.
Well, we are the science kids on YouTube,
Yeah,
and
we have a lot of viewers who are kids who are probably interested in the field you're in.
yes, and our question is, and I feel like this is a pretty important question, especially since we are the science kids. What would you tell to kids who are interested in pursuing space exploration or science in general?
Great question. Well, I think what you two both are doing is phenomenal as the science kids, and helping to, I think inspiration is a big thing, right? Helping to inspire others. At JPL, we have a thing called Each One Teach One, where we mentor, the older graybeards like myself will mentor people that come in. But I think to answer your question directly, it gets back to that following your passion, right? It sounds like you're right now passionate about aeronautical engineering. So, I would look for opportunities, figure out ways you can get involved in that field, through reading on your own, looking at basically, I'm sure there's lots of online courses now. As you go to, find out colleges that are, strong in aeronautical engineering, find others that are aeronautical engineers and talk to them. And actually I'll find, I can put you in contact with some folks that JPL, that are aeronautical engineers. So you can actually ask them, pointed questions about what they do. And there's many different things aeronautical engineers do. And I think, follow your passion and basically just be open to modifying, as opportunities and challenges, come up. I think that'd be the best advice I could give. Follow your passion.
All right. Thank you so much for this interview. You're our first interviewer. Set a high bar already. So to all of our viewers, thank you for watching. We hope you enjoyed this. Please let us know if you have any questions for our interviewee over here. And our motto: science is everywhere
And in everything.
and everything. Bye. Do you have any final comments for the viewers?
Nope. I love your motto and I love what you're doing. Keep it up.
Thank you so much. Have a good one.
It's been a really amazing time just interviewing you.
Thank you. I've really enjoyed it. You guys are great.